logged in when I log out, which
I'm
is
recording.
very weird. Okay, awesome. Okay. Alrighty. Okay, we're done. Okay, so yeah, I think, yeah, just remember everybody, Elna, pop your video off there. Okay, perfect. All right. Okie doke. So this lesson is the big planet. Jupiter is the biggest planet in our solar system, and its diameter is 13.5 times the size of Earth's diameter. That's 143,000 kilometers. That's a pretty monstrous planet. And what are we going to look at today? We're going to look at all the moons of Jupiter. Then we're going to look at the weather facts from McCormack. Then we're going to head over to mostly NASA and find out more about how sunspots and sunspot cycles and geomagnetic storms work. And then we've got 5 McCormack examples. They're not the best examples on the planet, but they will give us some idea. And, you know, sometimes I have to work really hard to get these McCormack examples to actually speak to our solar fire information of the same date. And honestly, this time I just didn't have time because it took me about 4 days just to do the sunspot section of the notes. It was very hectic. So, but nonetheless, though I'm presenting the examples more or less as he presented them, and it still illustrates the power of the Jupiter pattern relating to sunspots and geomagnetic storms, and then how that cascades into auroras and into seismic weather and seismic events, you know, like earthquakes and things. So yeah, it's an interesting, you know, the correlation between what they call space weather, which is all these cosmic rays that the sun and the rest of the universe, because there's 2 kinds of cosmic rays. There's the cosmic rays that come from the sun, and then there are cosmic rays that come from the Milky Way, which is our galaxy, which has 300 billion stars in it. And then there's another few 100,000 galaxies, and they are also sending cosmic rays our way, you know, on their way to wherever it's going. Right, so let's have a look at Jupiter's moons. I discovered that Jupiter has 79 moons at the last count, and 53 of these moons have names. I had no idea that Jupiter had that many moons. And the largest 4 are called the Galilean satellites, and that's because they were discovered and named by Galileo Galilei, and he first saw them in 1610. Right, so we have Io, Europa, Ganymede, and Callisto. Let's start with Ganymede. Ganymede is huge. It's larger than Mercury, and it's the largest moon in the solar system. Laurie, you got your
sorry.
sound on, no worries. Okay, so Ganymede is the largest moon in our solar system, and it's the only one that generates its own magnetic field. So, you know, it's a potent force, this Ganymede. Then we have Europa, which is mostly ice, water ice. And it's thought to have twice as much water as Earth. That's one massive amount of water. And astrobiologists think that it could have habitable zones. Because like here on Earth, we do have very different kind of life forms that thrive near underwater volcanoes and other extreme locations, which could be similar to what's available on Europa. Then there's Callisto, which is very ancient and it's very cratered, and it has a visible record of early history of our solar system. And at the moment, there's only a small amount of activity on the surface. And then Io is the most volcanically active body in the whole solar system. Its surface is covered in sulfur in different colors. And Jupiter's gravity causes tides in Io's surface that rise 100 meters off Io and generate heat for magnetic activity, and that drives off water. And then, yeah, so that's the kind of, just to give you some idea of this amazing solar system we find ourselves in. All right, so now we come back to McCormack. He says that Jupiter is the indigo ray of our solar system spectrum, and it's temperate in nature. So therefore, it's known in weather astrology as a preserver. It's the friend of outdoor people. So sportsmen, people wanting to having a lovely outdoor wedding. What else is there? Day trippers. So Jupiter's that friend, and we know it as a greater benefic, so it also wants to bring the goodness. Then the next thing that McCormack wants us to notice is that Jupiter has a sidereal period of 11.86 years. So what does sidereal period mean? It means that if you look at Jupiter against the background of the stars, let's just pick any star, like say Regulus, then it will take 11.86 years for Jupiter to do one whole cycle and come back to Regulus. That is different to what's called the synodic period, which is when you get a Jupiter-Sun conjunction. So Jupiter-Sun to the next Jupiter-Sun, and when we say Jupiter-Sun conjunction, the Earth is included because we are viewing that Jupiter-Sun conjunction from Earth. But according to McCormack, I haven't tested it out, if you know the synodic period, which we can get out of our ephemeris or out of our solar fire, if you know that date from conjunction to conjunction, you can calculate the sidereal period. But anyway, it's known. It's 11.86 years. And that figure is incredibly significant, which we're going to see when we come to sunspots. Okay, so what does Jupiter generally do? It raises the temperature. It raises the barometric pressure. And because you've got high barometric pressure, the air is going to come downwards over those areas where Jupiter is predominating. So, and because of that, you get the blue skies, because the wind and the moisture can't blow in and create clouds and things. Again, because of the high pressure, you get minimal humidity. And now in terms of the atmosphere, you get positive electricity. In other words, when Jupiter is dominating, then the atmosphere is positively charged. And you also get an increase in ozone, because ozone, in fact, is 3 oxygen molecules. So normally the stable oxygen that we have here on the lower atmosphere that's attached to where we hang out on Earth is O2. But in the higher atmosphere, because of all this charge that goes on, you get O3. And then that is a positively charged molecule, and it's unstable. It keeps, the third oxygen will pop off the one pair of oxygens, and then another pair, and there's a lot of activity that goes on around ozone. That's why it's used medically to sanitize, because it basically kills stuff. And I know our vet in town, she uses ozone to sanitize her surgeries and things after she's done a big op. And she also makes like raw pet food, and she sanitizes the whole place before she goes in and does her manufacturing and that kind of thing. So that's a bit about so ozone is associated, an increase in ozone is associated with Jupiter. And then I don't understand why he doesn't explain, but he says if there are winds associated with Jupiter, they're going to come from the polar regions. So in the northern hemisphere, they're going to come from the north. In the southern hemisphere, they're going to come from the south. But generally, you're going to not have so much wind because you're going to have these high pressures. All right. So now we're going to look at the combo. So if Jupiter and Mars are in aspect, and remember always the most potent is the conjunction, and then your squares, your oppositions, and so on. But don't discount your gentles, your sextiles and trines, because with planets this potent, they can override the gentleness of the aspect. All right, so Mars and Jupiter, we've got heat, drought, thunder, and earthquake stuff. When we put Jupiter with Saturn, then Saturn seems to dominate, or stormy Saturn. We get excessive humidity, cloudiness. The barometric pressure drops, the temperatures drop, the wind speed increases. You get these geomagnetic storms and you get earthquakes. Right, if we look at Uranus with Jupiter, do you remember Uranus is erratic? So you get sudden abnormal high pressures, sudden low temperatures, very high wind speeds, and they can also gust. Again, the geomagnetic storms and peculiar health conditions. I think you will also get some seismic stuff with that. And then Jupiter with Neptune, you get humidity again, because Neptune definitely brings humidity. You get stagnant conditions, and that's because of the humidity. So, it gets very, very close, hard to breathe. You get the higher temperatures, freak storms, which come from the Neptune, seismic activity, and pandemic disease. So we have to bear in mind that in April next year, we have a Jupiter-Neptune conjunction coming up. And so we must be looking out for that. And then we have the third and final Jupiter-Saturn square on the 24th of December. So first we must look for that and be prepared. And we're pretty much almost within orb. So, be prepared for disrupted weather and so on, and all the other bits and pieces that go along with that. And we will, when we do Saturn, we're going to track that third Jupiter-Saturn square across the world. We're going to do some storm tracking with Saturn. Okay, your combo signatures. Again, that self-study, you'll notice they're getting smaller and smaller because, it's like midpoints. As you go through, you've done all the other lower combinations. So it's just a couple. Right, now we head on to the new stuff. What I decided is, because McCormack was so adamant, even in his day, sunspot stuff was a big deal. And the conventional meteorologists were saying that the sunspots control the weather. So McCormack's contention was, yes, okay, there is definitely a relationship between the sunspots and the normal weather on Earth. I don't mean the geomagnetic weather. But his big thing was, as astrologers, we have one step ahead of that, because we know which planets are correlated with the sunspots. So sunspots happen approximately 11 years. Every 11 years is a new sunspot cycle. And so there's that 11.86 sidereal year that we're talking about. Quite exactly how they're correlated, he doesn't say. And there's various theories that are put forward. And honestly, I did not have time to go verify everything that he said. And so we can all look at it and try and figure out what events exactly are, what Jupiter planet combo events are correlated and in what way. I did make a start by putting a little table in your notes with the last three cycles, 23, 24, and 25, and putting the Jupiter perihelions and aphelions. And there is some sort of a correlation. It doesn't mark the exact beginning and end, but there's definitely like a rhythm that we can watch. So that's for further kind of study. So what are we looking at here? This is from 1600 until today, or still like 2020, let's say. We are looking at sunspots. The first one is an international sunspot series. Now, version 1 is this black, and then version 2, they've come along with red. And so you'll see there's some smoothing out and some changing. They've gone from those peaks over there and they've brought it down a bit. Quite how they do that, I do not know. These guys are very bright. They're NASA scientists, so we'll believe them for now. Okay, the middle section is the standard or Zurich cycle numbering system. So that's what we used to. So naught was here in about 1750. And currently we are on 25. So there's 20 sitting there, 21, 22, 23, 24. 25's here. Okay. 20, 21, 22, 23, 24. Yeah, we've just started in December 2019, we started cycle 25. And remember, those are those 11-year stories. Now, this bottom little section, this is another way to look at the same graph. And I think they're using ice cores and stuff, but don't quote me on that. What I want you guys to notice is from here, from about 1640 till about 1700, there's this thing called MM. MM is the Maunder minimum. And then there's another one here from about 1790 to about 1830, 35, or yeah, 1830. It's smaller, so it's shorter length. This is the Dalton minimum. Now, when these things happened, you got ice ages, mini ice ages. So just to bear that in mind, when the solar activity is really low, and here you can see it over here as well. This, I think, is even lower and for longer duration. So then more of the Earth starts to freeze over. Okay, so what are we looking at here? Here, we've got these weather balloons that are specially designed to measure cosmic radiation. They send them up into the stratosphere. This plot is from March of 2015 until June 2021. So that's pretty jolly recent. And this here is our radiation levels. So what they're showing is that in December, from December, well, let's just say March. Let's just go March, okay, because December's there. So March of 2015, right the way up here to December of 2019, you've got a solar cycle 24 weakening. And after that point, you now have the solar cycle strengthening. So it would appear, and again, don't quote me on this because I'm still learning this alongside you guys, that as the radiation increases, the sun, so this might be the other cosmic radiation that's getting measured, and the sun cycle is weakening. Then as the sun cycle strengthens, the amount of cosmic rays in our atmosphere, in our stratosphere, decreases. And this measurement was taken at California. You can see that little red dot there. That's the place in California where they send the balloon up. Right, so we are officially in solar cycle 25, which started December 2019. This is a lovely little movie from NASA. Right, so as they say, a picture tells 1,000 words. So what the next thing, we're coming back to McCormack now. And McCormack said that when Jupiter combines with Uranus or Saturn or Neptune or Pluto, you get an influence on solar activity. He said that you get strong magnetic fields and strong solar discharges on the sun's surface. And then he quotes this guy, Rudolf Mewers, I presume, or Mewers, a German scientist, who wrote in 1901 that the solar period of sunspots is influenced by, he actually said produced, which is interesting, by Jupiter, Saturn, and Uranus every 111 years. So 111 is 10 cycles of Jupiter and 4 cycles of Saturn and 1.5 cycles of Uranus. Presumably these are all sidereal cycles. And then he said there is also a 55-year intermittent cycle, which is 5 Jupiter cycles and 2 Saturn cycles. And this 55-year story gives us the greatest droughts, gives us epidemic disease, gives us changes in mass human psychology. And he quotes that the First World War from 1910 to 1920 happened in a significant part of one of these 55-year cycles. He doesn't give much more detail than that, so like lots to research here. But nonetheless, we've got, just the beginnings of something that could be quite fascinating. Right. Then there's also a 28-year cycle, which we know well from astrology. That's our Saturn cycle. And presumably the 28 years is sidereal, because the one we use is the Saturn to Saturn. Yeah, no, I think that is the sidereal. And then that brings minor floods and a flourishing of art and science. So you can see these guys monitored more than just the weather. And he said the greater the intensity of sunspots, if there is a drought, then the higher the likelihood of war. So there's another interesting mundane weather connection. And then Rudolf Mewers also said that there's another cycle, which is 1,351 years long. And that is when you get Jupiter, Saturn, and Uranus all coming to a very near conjunction. So, yeah, that I think could be quite an interesting time. So he gives one example, McCormack does, and that is the period 1940 to 1942, where we have Jupiter, Saturn, and Uranus in northern tropical Taurus or southern tropical Scorpio. Now, on the 8th of August, the 20th of August, 1940, as well as Feb of 1941, Jupiter and Saturn got together. That was followed by Jupiter conjoining Uranus in May of 1941, and then Saturn conjoining Uranus in May of 1942. So you can see these aren't very close, but nonetheless, they're pretty close. And they span pretty significant time on the planet. That was when the World War II was in its major throes, because that spanned 1939 to 1945. So just for interest, I just put a little chart that I found with some key information here about the World War II. Then McCormack, in your notes, you'll see another example. Now, that is a whole lot closer. That happens, I don't think many of us are going to be alive to see it, but it's 2079, 2080. Saturn and Uranus get together in February, August, and October 2079, and then Jupiter conjoins Uranus Jan 2080, and Jupiter conjoins Saturn March 2080. That is a lot closer than the one in the 1940-42. So he says, when these things happen, you can get electromagnetic phenomena, abnormal weather, you get mass psychology getting a bit messed up, you get seismic disturbances, lots of earthquakes, volcanoes, and major weather events and major political events. All right, so moving on, let's look at the layers of our Earth's atmosphere. Where we live and breathe and fly planes and hot air balloons and everything is a troposphere. And that extends to about, let's say, average 11 Ks above the surface of the Earth. So the temperatures range from an average of 15 to minus 56.5 degrees C. I don't have the Fahrenheit here yet. I will do it for a later version. So notice that the temperature goes down, okay, as you climb up the Earth's surface. So on the mountaintops, it's much colder than it is down in the valleys and at the coast. Then the troposphere is followed by the stratosphere. Notice that the stratosphere goes from minus 56 here at the join to minus 2. So that has warmed up quite considerably. And the stratosphere is where they send the weather balloons up to measure this cosmic radiation. Beyond the stratosphere is the mesosphere, which is 40 to 80 Ks above the surface of the Earth. There they have to send meteorological rockets. It's that far from Earth. And that's where the meteors fly through. It looks like they do get a little bit into our stratosphere as well. Here, the temperature goes from minus 2.5 all the way to minus 86. So that's pretty chilly. And then it would appear that the temperature flips again and goes from minus 86 to 1,200 degrees Celsius. When I first saw that, I thought, wow, maybe that should be minus, but I'm accepting it as it is. It did come from a reputable site. And this is the area where the auroras happen. So they're happening in the thermosphere. And then beyond the thermosphere, so that's the thermosphere extends from 80 Ks to 800 Ks. And then beyond that, we've got the exosphere, which is 800 to 3,000 Ks. And that's where our satellites and spaceships, our international space stations and whatnot hang out. And it seems to be this very hot 1,200 degrees C. So, we do live in a very fascinating world. Right, let's come back down closer to Earth and look at the level of radiation. So this is a graph that shows radiation naught is sea level. And then this is as you go up. This is actually the increase in radiation. So notice at around about 25,000 foot, which is 7,600 meters, you are sitting at, here, actually the radiation's here. You're sitting at 10 times. So it's not quite, it's actually a little bit lower than, anyway, they put the plane a bit higher. Okay, that's what they've done. Then at 40,000 foot, which is 12,000 meters, you are 50 times the radiation. And this is pretty strong, and then here you're even higher, okay? And this is not fun radiation. This is X-rays, like you get in a medical X-ray machine and like you get in an airport scanning machine. It's pretty damaging stuff, so you don't want to be too exposed here. So, it's a bit worrying, I think, for people who are, like pilots, like Laurie's hubby and all the flight staff and that spend so much of their life at these high altitudes. You wonder about how they get protected. Well, I did anyway. So the higher we go, the more radiation we're going to absorb. Right, then moving on, what they have discovered, okay, is that there are two types of cosmic radiation, which I mentioned earlier. The one is the galactic cosmic radiation and the extragalactic. So the galactic is what comes from our own Milky Way, and then the extragalactic is beyond our Milky Way. And then we get solar energetic particles. So these are high energy particles, and they were first observed in the 1940s. They consist of protons. Now, a proton is an atom that's stripped of its electrons. And then there's separate electrons, and then there's high energy ions. So now a high energy ion, and these have high atomic weight. So an example is something like oxygen, carbon, magnesium, silicon, and iron. So these are big atoms, and they've been stripped of electrons. They're just the positive charges. And that gives them a huge amount of energy because they want to get back to balance. They want to draw electrons in. Anyway, we're not doing too much physics here, but what happens when these high energy particles hit the top of our atmosphere? This is this particle coming in. It collides with an atmospheric molecule. One proton will collide with an atmospheric molecule, and then you get this splitting out, what's called an air shower, of all kinds of cosmic particles. And that is this radiation. All these funny Greek letters here are various different kinds of radiation. And here are our positive electrons. There's our electrons, and I don't know what an E plus is, but an E minus is an electron. We don't have to know this, but just know that this is what's happening on a daily basis up in the top of our atmosphere. And this word air shower was coined by a very brilliant physicist called Bruno Rossi. So here's some more interesting history. This guy Hess, he in 1912, he got in a balloon, an air balloon, with 3 Wolf electrometers. So that was newly designed, and they detect cosmic radiation. And he went up to 5,300 meters. He picked a near total eclipse because he wanted the moon to block the sun's visible radiation and to see what other radiation's out there. And he was the one who discovered that the radiation rises as you increase in altitude. And he said at the level he got to, it was 4 times the rate of ground level. And this little photograph shows him landing after his flight. And then in 1936, he got the Physics Nobel Prize for discovering that. So that was quite an amazing mind. This is a bit technical, but it shows a weather balloon in the minutes after you release it. So from 1 minute to 157 minutes. Just check, people. Somebody's got your sound on, and I can hear some chatting going on or some noise in the background. Just check your sounds for me. Okay, so we've got the weather. This is our little weather balloon, and it rises up into the air, and here it goes through the troposphere. Now there's a thing called a tropopause, which is between troposphere and stratosphere, and just as it gets into the troposphere proper, it gets to what's called the Regeno-Fotzer maximum radiation. Then the little balloon pops and descends back to Earth. So this is quite a famous thing, this Regeno-Fotzer maximum. And I have given you more info in your notes. Right. Now, what are we looking at here? This is our good old sun. And this is one of its famous things that it produces. It's called a coronal mass ejection. And it basically spits out fireballs on a gigantic scale. This one was captured on the 18th of June 2015 by one of NASA's observatory spacecrafts. And so what happens is these things are associated with these things create geomagnetic storms on Earth. And so, and when you get that, you get auroras. So one of the biggest coronal mass ejections that ever happened in recorded history, one of the most intense, happened on the 1st of September 1859. It's called the Carrington event. And it took 17.5 hours to get from the sun to the Earth, and it set off a monumental geomagnetic storm. They saw the auroras in the Caribbean. Now that is close to the equator. So that is a pretty amazing aurora. And the telegraph lines, so you must know this is 1859 when the telegraphs and the telephones were sort of coming in. They caught fire, that they were so charged up and so on. And communication was disrupted across the world. Right, so for about 100 years, the scientists have known that there is a roughly 11-year cycle. And then the major events like the Carrington, they're not quite sure what kind of cycle they're on, but they could relate to those longer cycles that we saw earlier, which that German scientist Rudolf Muse postulated. But they do say the Carrington event happened 6 months before the peak of solar cycle 10. Right. They also found that the most extreme, this guy, Matthew Owens, he's a space physics professor at Reading University in the UK. He found that the most extreme coronal mass ejections happened during the peak solar activity time. And he said, those are the ones we have to worry, that we have to worry about. So what happens? Okay, what kind of effects? Basically, when there's a geomagnetic form, it affects the Earth's magnetic fields. It also affects the magnetic fields that are around big power lines, because when you have moving electricity in a power line, there is automatically a field generated around it. It's got I did study it somewhere along the line, but forgotten the name. There's a name for the whole thing. Anyway, just trust me, it's been proven very clearly that that's how it works. And so basically, it upsets that magnetic field, and then it upsets the electricity. So you can damage and blow out transformers, you can get power outages. And the most serious recent event was in March 89, and 6 million people were left without power in Quebec, Canada for 9 hours because of one of these storms. And so now what they're doing is the National Oceanic and Atmospheric Administration Space Weather Prediction Center is actually providing predictions of the weather, of the space weather. And the reason for that is if they're going to do maintenance on a power grid somewhere, you definitely don't want people on the transformers working on the power lines during a geomagnetic storm. They're going to die for sure. And then the other thing that they recently did, there was some there was an Ingenuity Mars helicopter that was going for its second flight in April this year. And they knew that there would be a coronal mass ejection on the 17th of April, 2021. So they timed it. They waited. They didn't let that little helicopter fly until that thing had safely passed. So we're learning how to work with these big events on the sun so that what we do doesn't get so damaged. Okay, moving on. Here is another image. This one was taken in August 2012. There's our tiny Earth, and this is the chunk of the sun with this very long filament of solar material, which was hovering in the sun's atmosphere. The sun's atmosphere is called the corona, because basically the sun is a giant nuclear fusion bomb, pretty much. That's the chemistry of the sun. It's not a fission bomb, which is what we make. It's a fusion bomb, which requires monumental amount of temperature and so on to do, and it's self-sustaining. It just keeps on going. Anyway, it threw out this ginormous filament, and that became a coronal mass ejection when it broke off. It traveled at 900 miles a second. Now that is pretty fast. I haven't put the kilometerage here yet. The coronal mass ejection connected with our magnetosphere and caused auroras to appear on the night of the 3rd of September 2012. So this little image comes from the NASA Goddard Space Flight Center. Here we have post-flare loops. So that's another thing that the sun does. It does solar flares. And what happens after the flares happened, these loops form, and basically it's the gravity of the sun is pulling back this very hot magnetic plasma. Plasma is a fourth state of matter, because you get solid, liquid, and gas. Then you get plasma, which is a very hot, charged, flowing state of matter. And they because they're all magnetic, they loop back in to the sun. And this was taken by an amateur astronomer. I thought that was a rather lovely pic. Alrighty, so enough on all this NASA complicated stuff, which is fascinating, but yeah, lots more to learn for me, I'm sure for you guys as well. But nonetheless, it's important to know, because this really has a huge effect on us and on our planet. And yeah, and Jupiter is the timer. So isn't that amazing? Right, so we're back at McCormack. And the first set of examples that he does is earthquakes. So what we're looking at here, the inner circle, the actual earthquake happened on the 10th of March, 1933 at Los Angeles at 6 in the afternoon. And so what he wanted us to notice, okay, so if we look at the actual earthquake, there's the ascendant, Jupiter's applying to the ascendant, squaring the midheaven. The sun is opposing the ascendant. And we've got Moon and Mars applying to Neptune. We've got a nodal axis sitting here. But what he found even more significant, we've got Venus sitting there. No, that's a little bit out. No, the sun's important. Okay, let's leave it like that. Then, but he wanted us to know that there was a total solar eclipse the previous year in August. And that happened at 8 degrees of Virgo. And so when the earthquake happened, Neptune had moved along and it was triggering that very sensitive eclipse degree. And this is also true in natal. If you've got a planet that's eclipsed, that becomes a sensitive point and it can be for up to 3 years afterwards. And if another planet comes by transit, like a Mars or a Saturn or Uranus, that is you're going to know about it. Whatever that planet stands for, the house it's in, all that stuff, it's going to be triggered. So the Neptune in the earthquake chart triggered the eclipse. Mars triggered the Neptune, and this eclipse, he wanted us to notice that Neptune was sitting very, very close to that eclipse. Now, in eclipses, if you've got a significant planet in very close orb, that planet becomes a ruling planet of that eclipse, as well as the Mercury, which is a ruler of the Sun, Moon in Virgo. So it's significant. So Mars was triggering the Neptune, and the Moon was going to trigger all of those things in the next, because it's sitting at 6. I mean, it's going to be a couple of hours and the Moon will have triggered all of that. So that's what he wanted us to notice here. So eclipses, he didn't say, what he said eclipses don't necessarily cause it, but they're part of it, but then they need to be triggered. And so he's showing us this trigger here. But the next one he wanted us to look at was South Carolina, Charleston in South Carolina. And what we got here is that in the first house, on this eclipse, which happened on the 29th of August, 1886, we had Jupiter and Uranus. So we know they're a seismic combination. That is in the first house. And what he said on the 31st of August, 1886, there was a severe earthquake in Charleston, South Carolina. So, yeah, there we go. Now, let's look at example 2. Example 2 is Jupiter-Uranus, the effect on weather and the geomagnetic storms. So on the 13th of May, 1921, that's our outer wheel, we have Jupiter. Oh, no, wait, let's start on the inner wheel. 3rd of May, 1921, we've got Jupiter-Uranus opposition. There it sits. And this is New York City. Then on the 13th of May, we have the next opposition, Jupiter-Uranus at 9 degrees. And on the 13th of May, there was a very unusual aurora borealis seen from New York, and cables burnt out mysteriously. So we know if that's happening, if you read in the newspapers, and like I've been posting in our Facebook group, there's quite a lot of aurora borealis going on. That tells us that there is geomagnetic storms, and that tells us there's a lot of solar radiation coming in. There are these coronal mass ejections coming in and sweeping through our atmosphere. Okie dokes, that's the one. Next one he wanted us to see was July of 1927, still in New York City. Here we have a Jupiter-Uranus conjunction at 3 degrees of Aries. We know Aries is stormy. And what he said was on the 15th of July, and that's like literally within hours of this exact conjunction, which happened at 5 in the afternoon. So it might have been at the same time. He said 3 inches of rain fell within 24 hours in New York City. That was the one thing. And then he wanted us to see the declination. Notice that for July of 1927, this is the 0 degree, and literally Jupiter is in the celestial equator. So, and pretty close to Uranus as well. So not only were they conjoined by longitude, they were also very darn close by declination. All right, let's go to August of 1927. So now he's tracking this Jupiter-Uranus conjunction. Here is the next conjunction. It's in the 8th house, but you know, when you've got these big patterns, you have got to pay attention to them. So they are conjoined. I don't know why I wrote Scorpio, because it's not true. They're conjoined in Aries. So my bad. Yeah, I don't know why I wrote that. So ignore that, please. We're back in New York City. Notice here again, the Jupiter is still pretty jolly close to that celestial equator. And we've got Venus cutting through. And of course, the moon is going to cut through twice, well, 4 times, 1, 2, 3 times in this month. Okay, and then we're on to January of 1928. So that's the third one. Again, now they meet up at 0 degrees of Aries. So we're still in stormy Aries. And at this point, they are also parallel. So what happens here for January of 1928? Notice that you've got this here. Towards the end, there is the parallel. Okay. So you want to, when 2 big planets hit a parallel, you must sit up and take notice. And around that time, we do have the moon also going parallel to both of them. So what actually happened? In August of 1927, the temperatures were well below the normal average. Now remember, August is the height of summer in the Northern Hemisphere, and it was excessive rainfall. And he said the English Channel had one of its worst summers in recorded history. All right, so what I want you to do here, in your notes on page 21, I made a mistake. I labeled the declination as the declination August 1928. It should read 1927. Below that, I talk about it. I say the New York Weather Bureau forecasters reported that August of 1927 was the worst August in the history of the local weather bureau from 1871. The average temperature was 5 degrees below normal. It was the coldest August on record. And across the whole Northern Hemisphere, they had rain, rain, and more rain. Now with this January 1928, what we had there was, he said, during the noon hour on the 25th of Jan, they had a wind of 130 kilometers an hour, which is 80 miles an hour. Now that is an astonishingly fast wind. In the winds here that blew the garden route fires in 2017 from where I am all the way down to Port Elizabeth, which is like 300 kilometers away, we're doing 90 to 100 kilometers an hour. So you must know, this is one wild wind. And New York is famous for its shop windows and for its advertising. So thousands of shop windows got blown in because they were glass and they just got blown away. And many, many of the large display advertising boards were blown down. And then the suburbs around New York, they reckoned that they had winds that were gusting at 90 miles an hour, which is 145 kilometers an hour. So that is pretty jolly hectic. Okay, so now we're going to look at an example that doesn't have any charts. And this is a guy called Dr. Luke Broughton. So he was a medical doctor. He wrote a book called Elements of Astrology. And he was one of these fine doctors who also believed in astrology, which is fantastic. So he noticed that Jupiter is perihelion in Aries. So that's nearest the sun at periods of 11.86 years. That is the same as the Jupiter sidereal period. And he related that to the spread of epidemic disease. So he in his book, he said in August of 1871, the New York Medical Journal stated that in Haridwar, India, every 12 years since 1782, all the way up to 1871, so the last one was in 1867, in this journal, there was a cholera outbreak. So that's pretty interesting. And then Broughton also noted that in 1881 and 1892, there was typhus outbreak in New York. And in 1892, 1893, there was again cholera in Germany, France, Russia, Spain, and Italy. And not only was there disease, but at the same time as these outbreaks occurred, there were also cloudbursts, cyclones, and earthquakes. So how fascinating is that? Right. Example 4 is auroras, hurricanes, and seismic. So here, please, I drew this chart up. I entitled it the wrong thing. I've said 31 Jan 1928. It should read 1938. It is 1938. And, you know, the data actually is 1938. I just put the wrong title. So just bear that in mind. I have put the right date here. We have Jupiter squaring Uranus. And what he wanted us to notice was that on the 17th of Jan, Uranus had gone stationary direct. So that means Uranus was very, very slow when it squared Jupiter, or when Jupiter squared it on the 31st of Jan. Also around about the 16th, we had the moon translating the Jupiter-Uranus square. Here on the 16th, it opposes Jupiter and then it comes along to square Uranus. So when you get a translation of these big patterns, you must sit up and take notice. The other thing just to bear in mind is you also on around about that same date, you've got Mars opposition Neptune. So that's also something we want to keep an eye out for. That is Pisces Virgo. So what happened? On the 17th of Jan 1938, there were, on the 18th of Jan 1938, there were frigid Arctic currents that came down over the eastern states, in other words, those Atlantic states in America. And in New York City, the temperature went down to minus 18 degrees Celsius or minus 26. I meant to put the Fahrenheit. Oh, it was 0 Fahrenheit. That's what it was. And then at Albany, which is in New York State, it was minus 26 Celsius or minus 16 Fahrenheit. And then over the same period in Quebec, Canada, we had minus 41 Celsius or minus 42 Fahrenheit. Heaven knows why it's so close, but I Googled it, so hopefully that's correct. But anyway, it was jolly, jolly cold. That's the main thing to bear in mind. Okay, then if we take a look closer to the time of the actual square, which is here, by the way, I didn't mark it in. So there it is on the 31st of Jan, Jupiter square Uranus at 9 Aquarius Taurus. Okay, first of all, we have Mars parallel Saturn on the 26th. Then we have Sun parallel Jupiter. I'm just looking for a Sun parallel. No, okay, we've got a Sun parallel Jupiter. And then that's on the 27th, and on the 28th, we've got Mars trining Pluto. Now remember, these are two hectic planets, so they will overcome that trine. So what happened? Here he said that wire communications throughout Canada were disrupted by magnetic storms, and that on the 20th of Jan, a sunspot, which was estimated to have an area of 3 billion square miles. So that is pretty ginormous. It was one of the largest ever seen by the Royal Observatory in London, and they'd been keeping records since 1875. So on the 23rd of Jan, the Coast and Geodetic Survey said that there were very severe magnetic storms, which began in the middle of the night. They disrupted shortwave radio transmission completely. And they weren't sure what the cause was, but it's known now that that definitely is sunspot related. And on the 23rd of Jan, in Hawaii, there was the worst earthquake in 11 years. It was a magnitude 6.6, and it was 16 miles east of Maui in Hawaii. It was 10 kilometers below the surface. And then in London on the 26th, that is when we had our Mars parallel Saturn, there was a headline which was reported in the New York Post about London. It says, it was not the end of the world. It was not a new war. It was not a fire. By press, radio, and telephone, officials explained that the aurora, rarely seen in southern or western Europe, caused by an electrical disturbance on the sun's surface. So this is what the people were seeing in the sky. The lights were clearly seen in Italy, Spain, Portugal, even the southernmost Gibraltar, Austria, Switzerland, Netherlands, British Isles. Phone systems were disrupted, shortwave radio between London and New York disrupted. And at the time, radio was huge. This is 1938. And on the 29th of Jan, so that's just after we've had our Mars-Pluto trine, there were winds which reached up to 90 miles. Again, that's like 145 kilometer an hour winds. Hurricane force raked the British Isles. There was property damage, sea travel disrupted, rain, sleet, and hail borne by these raging winds, and Scotland was really badly hit. And during the same period in America, in the eastern states again, a plane that was flying from Newark, New Jersey to Washington got caught in this 80-mile-an-hour gale. That's our 120 kilometer an hour winds. That was blown all the way back to Hartford, Connecticut. That's quite a far way. So, these things cause some severe things. So this is just a little summary of what I've already mentioned. And this is our example 5. So example 5 is Jupiter conjunct Uranus in 1941. So the first thing he mentions, McCormack, is that during this time there was a lot of censorship because World War II was happening, and so weather was important information. Anyway, in spite of that, he said that on the 16th of May, the sun went parallel to Jupiter and Uranus. So let's get to the 16th of May. There's the sun parallel Uranus, and there's the sun parallel Jupiter on the 15th, actually. And so basically here we have the sun activating both Jupiter and Uranus, which actually are conjunct on the 7th of May. So on the 16th of May in Columbus, Ohio, there were cyclonic winds, and it was huge property damage in central Ohio, and that was 80 miles an hour winds. Then in Chicago, Illinois, the winds were doing 70 miles an hour. They destroyed 40 airplanes. I presume they were stuck where? Standing on the tarmac. They blew down 4 hangars, shattered windows, wrecked hundreds of chimneys, and left many outlying highways full of fallen trees during a thunderstorm. And same date in Kendallville, Indiana, there was a heavy windstorm. Power lines were blown down, and that closed the factories. Roofs of 10 buildings were damaged, and trees were uprooted. So, this is potent. Those declinations are potent. We have to pay very careful attention, especially the parallel. Okay, and lastly, on the 16th of May in Pasadena, California, there was a very, very strong earthquake. And he was waiting for this because he knew he could see 16, 15 May was a significant date. So he was scanning the headlines to see what did that bring. And it definitely brought some hectic stuff. So with that, I've just summarized that as well, what we just mentioned. Here, it's all in your notes as well. Here is our assignment. Again, just the prediction. Lunar quarter chart 6, which is our third quarter, 28th of October 2021. Now, what I'd like you to do is correct your notes, because your notes, I changed the lunar quarter number, but I didn't change the information. So it's not new moon dated 6th of October that you've done. It's the third quarter dated 28 October 2021. So please change that. And lunar quarter 7 is the new moon dated 4th of November 2021. And so if you can hand that in by Sunday, before Sunday, the 21st of November, that'll be wonderful. And so that is the end of our lesson. I'll just leave this up for a few minutes more so you can just make sure you write it in. It's also in, sent out that list of all the lunar quarters. It is there. So it's definitely 6 and 7. Okay. So that's it. I'm going to end the presentation. Stop recording. Yeah.